All right, let's start off with an example in processing about arrays, and let's see how arrays are represented in memory. I would like you guys to pay special attention when I draw memory diagrams, and I would like you to be able to reproduce memory diagrams of exact same detail level that I produce them. So the notation that I use for memory diagrams, you guys are to produce exact same notation. Let's say if we have void setup, so our setup function, and if we have int a, and let's have an array. So with an array, in order to say this is an array, we need to have open and close brackets. And I could name my array anything. It's better to use meaningful variable names. Here I'm just going to use any names to really show what how arrays are working. So let's say we have x, and we're going to have new int 3. So anytime you use the word new, that means that you're asking the computer to give you more memory. This is actually allocated, dynamically allocated memory. We are not going to be talking about dynamic allocated memory in this course just because it is beyond the scope of this course. It's important that you guys follow what I do in the memory diagrams. Memory diagrams are extremely important. I should, however, tell you that our perception of memory using our memory diagrams in this course is a little bit naive, but it's okay because it gives us an overall perspective of how the computer's memory operates, and it's just like learning the ideal gas law. So you don't know you can't precisely model how the gas behaves, but the ideal gas law gives you a pretty good idea. It's the same thing with our memory diagrams. So when you say new, that means you are requesting extra memory from the computer, because you can have an array of size 3 or you can have an array of size 10,000 or more, right? So then I'm going to have int array y, and this time I'm actually just going to initialize my array right away to, let's say, 11, 12, 13, and 14. Okay. Then I'm going to have another array, int z. All right, let's see how this looks in memory. So I'll separate this out. So this is my setup function, and we're going to start looking at the instructions from over here. Let me just change the color of my. So we're going to start from the first line, obviously. So a is 20, so nothing new there. We're going to have an integer 20. Then we have x new. So the memory consumed by our program actually gets larger because we are requesting more memory now, right? So we're going to get x, and x, it looks a lot like the strings. So this is index 0, index 1, index 2, and don't forget they're all initialized to 0 by default. So that was for this line. Then we go to the third line and we say int y. So y is declared and initialized to these values right away. So we're going to have 11, 12, 13, and 14. And indices, maybe it's wiser if I do indices with the different colors, 0, 1, 2, and 3. Okay, and then we have array Z. So array Z, it hasn't been declared. It has been declared, but it has not been initialized. Also, we have not requested more memory for it. So Z is just going to sit like an empty space. So there's nothing there. So let's add some more code to this and see how things go. So we executed this one as well. Let's add more. So for instance, if I said X let's just go. If I said X index 1 equal, let's say 12, what happens is when I execute this line, we're going to go to X index 1, and this is going to be changed to 12. So if I said print x1, 12 is going to be printed. Similarly, if I say y go index 1 and we change that to 30, we're going to go to y index 1, it contains 12 now, it's going to be changed to 30. Now if I have another one, if I said z index 1, change that to 20, what happens is this is not allowed. It is a mistake because of the fact that z does not have index 1. So I cannot have that. So what I can have instead is I could now, because I have z, I could set z equal new integer two. So now I'm actually saying that z is an array of size 2, 0, and 1, and they're all index 0. So now at this point, I could go and say z index 1 equal 20, and 1 is going to change to 20. Make sense? So let's do a couple more. What if I did this? What if I came here and I said y equal new int 5? What happens then? So what happens is that y already is declared and initialized, and if I do this, if I get y to basically, if I declare a new array for y, what happens? Because y already has a value. Well, it's simple. Basically, the old value is going to be discarded. What happens is this value, it's going to be gone. So this is going to be gone, and y is going to have a new value. So instead, basically, this is going to be gone, And now y is assigned to a new array 0, 1, 2, 3, 4, 5 cells, and each cell is going to be initialized to 0, right? Because I'm declaring a new array for y. I'm requesting a new bit of memory for y, so that's why what it contained before its history, and it can be done with any array. All right, let's go ahead and actually program some of these in processing. So let's say my setup function, I have an array. So I'm just going to say int, open and close brackets, we call it R, equal new int, and we'll just say size 4. Okay. And so we have an array called R, and it has size 4. Now, if I go ahead and say print for me what is in index 0, processing is going to print 0. If I say print what is in index 1, that's what's going to be printed. So index 0 and index 1, they both contain 0. Index 2 and index 3 also contain 0. A really cool built-in feature in processing is that if I just go ahead and I say print, and I said, well, show me what's inside of R, what it does, it actually does array notation. So it says in index 0, you have 0, in index 1 you have 0, in index 2 you have 0, and index 3 you have 0. So if in here I went and said, for example, R index 2 equal 7, and I try to run this, you see index 2 now contains 7. And if I try to say R index 4, and I try to set that to 8, what happens? Well, this shouldn't work, right? Because index 4, we don't have index 4. We have index 0, 1, 2, and 3. So if I try to run this, I get an out of bounds exception because we don't have index 4. It's perfectly happy if I try to put something in index 3. So if I try to run this, it's working perfectly. So let's do a case where I change this. So right now, this is what I have, right? I have array, and I'm setting it to, basically it's going to have 4 cells. It's going to have 7 and 8. What if, so I said here, reassigning R. So let me just draw the memory right now. So right now, I have setup, I have R 0, 1, 2, 3. They all contain 0 to begin with, and I've altered a couple of them. So I've changed 2 to 7, and I've changed 3 to 8. Okay, that's what I have. Now, what if I go ahead and I say R equal new int 2. What if I do that? If I do this, basically, or actually, let me just to make a point, I'll make this into 5. Basically, what I said is going to happen is this guy is going to get destroyed. So we'll just go ahead and delete it. Basically, R is going to contain 5 slots, so 0, 1, 2, 3, and 4, and they're all going to be filled with zeros. Let's see if this is the case. So if I go ahead and I say, okay, now print R, let's see what kind of an output we're going to get. So we see that before reassigning, we had 4, we have 0, 0, and then 7, 8. After reassigning, we have a new array that has 4 cells now, and it's all initialized to 0. So that's how this thing works. Let's answer a question, and then we're going to discuss how to actually add in one element to the end of an array, and we're going to discuss how to discover the size of an array. Thank you.